In section 3, we're going to look at basic function operations. So two things to consider quick. One is, what is a function? That was something that we talked about way back in chapter 1 or chapter 2. A function, remember, is a relation where each input goes to only one output. So each thing that we put into a function only spits out one value. If we were to consider the graph, it passes the vertical line test. If we pass a vertical line through at any point, it only intersects one point at a time. So we're looking at functions. And then basic operations would include addition, subtraction, multiplication, division. So we're just combining functions through those operations. So this should be similar to what we did in chapter 5, where we added, subtracted, multiplied, divided polynomials. In order to do these, you'll need to be given two or more functions. So here we have f of x equals 2x plus 3, g of x equals x squared plus 1. The first operation that we're given is f of x plus g of x. So we take f of x, which is 2x plus 3, and we are adding g of x, which is x squared plus 1. And so from there we just look to combine like terms. So we have an x squared with nothing else to add to it. We have plus 2x. And then we can combine plus 3 and plus 1 to get plus 4. So f of x plus g of x is x squared plus 2x plus 4. F of x minus g of x, not that different, very similar, except we just have a minus sign between there. So we have 2x plus 3 minus, and here we do have to be careful because we have to subtract the entire function g of x. So make sure that you include parentheses so that that negative gets distributed to both terms of g of x. If we don't put those parentheses, then we just have minus x plus 1, and that plus 1 is going to be positive, but we need that minus to go to it, so it should be negative. So again, we just look to combine like terms. So we don't have an x squared here on the left, so we have minus an x squared, so we're going to have negative x squared. 2x minus nothing on the right, so a positive 2x. And then 3 minus 1 gives us plus 2. So f of x minus g of x is negative x squared plus 2x plus 2. If we had switched this operation around, if we had instead done g of x minus f of x, if we had done that, that would come out to something different because changing the order of subtraction changes things. If we had switched above and done g of x plus f of x, that would come out to the same thing because addition is commutative. We can rearrange the order of that and things still work out the same. Our last basic operations are multiplication and division. So similar setup, we just plug in the function that we're given and see what we can combine or reduce. So here we have f of x, so 2x plus 3, times g of x, so times x squared plus 1. And this should look very familiar to one that you might have done in chapter 5 where we multiplied polynomials, because that's exactly what we're doing in this specific example. So we just have to distribute, make sure that we hit all the terms. So we have 2x times x squared, which is 2x cubed. 2x times 1 is going to be plus 2x. 3 times x squared is going to be plus 3x squared. And I'm just rearranging things so that we have powers largest to smallest. And then lastly, 3 times 1, so we have plus 3. And that's it. Nothing that we can combine there. And our last example with division, here we have g of x divided by f of x. So we have g of x, so x squared plus 1, divided by f of x, so divided by 2x plus 3. And that actually is all we can do with that one. There's nothing that we can pull out on the top and on the bottom that would cancel out. So we're stuck right there, and that's as far as we can go with that example. But if we had something that we could pull out of the top, or factor on the top and factor on the bottom, and then we have something in common on top and bottom, then we can go ahead and reduce that and simplify it a little bit.